All right, it's Tuesday. Today we're going to be talking about choosing the correct line of best fit. We now know how to do linear, quadratic, and exponential. So I'm going to give you a data set and ask you to find the appropriate line of best fit. And basically the gist, this is not a hard process. Basically, we're going to type in the data into our stat thing. We're going to look at the graph or look at the data points. And then we're going to decide, does this look linear, quadratic, or exponential? Linear is usually pretty easy to spot. We are going to do that mode stat diagnostics on to verify if it's linear or not. Quadratic and exponential can look very, very similar. Sometimes it's almost so similar you can't really tell the difference. But the ones I'm going to give you are going to be a little different, so they won't be obvious, but you will need to run both regressions and compare those graphs to know which one it actually is. So I just have 3 examples. Hopefully not a long day, but I've said that before every single day. All right, so using your graphing calculator, find the line of best fit. So here's our data. So I'm just going to go ahead and go over here and go to stat. And I'm going to go ahead and enter my data. So I'm just going to pause to save time. All right, so I've got my data entered. I am going to go ahead and run through the whole process each time. I'm only doing it 3 times, just so you can see. So I would always definitely do second stat plot, turn that guy on, turn it on, and I would zoom 9. Every single time, I would do that first. Okay, this one, just looking at it, hopefully you can see there's some sort of curve in there, so it's probably not linear, but I do want to show you the process of running through that linear every time. So if you're going to run a linear diagnostic, a linear regression, I would run the diagnostics. So I am going to go ahead and press mode, and you can scroll up or scroll down, and go to stat diagnostics, and go ahead and turn that on. Okay? And then I'm just going to run, I'm going to do linear first because it's pretty much like obvious it's not linear. So I'm going to go to stat, I'm going to go to calc, I'm going to go to linreg number 4. And you have to do that store regression equation because I've got to look at it. So I'm going to go to vars, I'm going to go over to yvars, I'm going to go to function, enter, y sub 1, enter, enter, enter. All right, so when it comes down, it's going to give me that R value, so 0.98. Well, 0.98 actually is a pretty good value. So that's not too misleading, but once you graph it, then you have a better idea. Okay, so graphing it, I mean, this point's off, this point, this point, this point, and this point. It's really only hitting 2 points, so it's okay. I mean, if I had no other options, 0.98 is a pretty good correlation coefficient, but it doesn't look so great. So linear, probably not. Let's go ahead and run another one. So I'm going to go to stat, I'm going to go to calc, I'm going to go to, I pressed down accidentally. I'm going to go to calc, I'm going to go to quadreg, so number 5, and enter, enter, enter. Store regression equation. I'm going to go to vars, I'm going to go to yvars, I'm going to go to function, y sub 1, enter, enter, enter. And I wouldn't write this down just yet. I like to just look at it first. Running the regressions doesn't take very long. So I'm going to go to zoom and go to zoom 9. All right, now some of these can be super, super close. So you need to either take an actual screenshot or take a mental snapshot of this regression. So in my mind, I'm going, okay, it hits all the dots. It's got maybe 1 dot that's kind of off, but for the most part, it looks pretty accurate. Okay, so now I'm going to run the last one, stat, calc, exponential regression is a number 0, enter, 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 store regression equation, vars, yvars, enter, 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 boom. Okay, and then this R or R squared may show up. The R is only accurate for linear regressions. The R squared is not super accurate, and there's you'll do that later, but sometimes the higher the number, the better. So on that quadratic, it actually was 0.9 something. Here it's 0.85, but in the end, really, it has to do with the eye test. Ooh, yeah, this definitely ain't exponential. So this one has several that are off, but you wouldn't know that by looking at it. I mean, exponential can be very slow progress. So it just really depends on the mathematics. So this guy is not exponential. So unfortunately, I do have to go back and run that quadreg again. So I'm going to go to stat, I'm going to go to calc, I'm going to go to quadreg number 5, quadreg, and I don't need to store that regression equation anymore because I've now compared all of them. I can just go down to calculate, and I can just go, and you can see that R squared is 0.99. So that's not the perfect mathematical thing. I wouldn't trust that number just because it is, you're going to use it later, but it's mostly accurate. All right, so I'm going to say y equals, and I'm going to say 3.89x squared plus 3.75x minus 5.14. And that is it. That is my quadratic, and I'll go ahead and write this guy with quad That is my quadratic regression equation. All right, let's go ahead and do it again with the next one. All right, here's my next data set. Just looking at it, I see they both go up on both sides. It doesn't look linear probably just looking at it because I go from 1 to 3 to 7 to 43 to 72 to 108, like the numbers are jumping. So probably not linear, but again, you really can't tell because the numbers on the side are counting not by even numbers over there, not by some sort of pattern. So I'm going to go ahead and use my calculator. All right, I do want to show you, in case you don't want a second plus 712 and then have to turn that mode back on and all that jazz, you can just go ahead and clear stuff. The only issue really ends up being that equation stored in that y equals whatever. So you can just clear that guy if you want to, and then go to stat, and then go to edit, and you'll just need to type over the data. So you need to press over, and you'll just need to actually physically type over it. And when you type over it, just press enter, it actually does type over that data. 40, okay, I'm gonna go ahead and pause and then finish typing over that data. All right, and I left the last one filled in case for some reason your data doesn't have enough points. You can actually just press the delete button when you're highlighting one of those data points if you have too many, if you don't choose to do the clearing the calculator option. But I actually do have a point there, so I do need to type it in. I just want to show you how to do that. All right, so my data is typed in. First things first, you gotta look at it. I've gotta know what I'm dealing with here. So if you've already turned your stat plots on, then cool, you can just go straight to Zoom 9. You do need to press Zoom 9 again because now it's gonna match the data around your new, or match the graph around your new data points if you didn't choose to clear your calculator. Otherwise, do your stat plot and turn it on all jazz. Okay, this guy, just looking at him, he does look exponential, but you really never can tell. Sometimes I've been tricked. All right, so I'm gonna go to stats. I still have my mode, my stat diagnostics turned on. So if you did clear your calculator, go ahead and turn that back on. I'm going to go to calc. I'm going to go to lin reg number 4. I'm going to go to enter, store regression equation, vars, over, enter. Hopefully we done enough. All right, looking at that, 0.87 for my R value, my correlation coefficient. That means this guy is not doing a pretty good job. So if I go look at that, Zoom 9, I mean, I can see I'm even touching just barely 1 point, and then the others are all completely off. This is not linear, obviously. So I'm going to go down to quad reg number 5. I'm going to go enter, store regression equation. Hopefully I'm not going too fast. I mean, hopefully by now you're like, yeah, I've got this. I don't want to go too fast, but also I don't want to have a 15-minute video on solving 3 problems here. Okay, my R squared is 0.96. But again, it really has to do with the visual test. I'm going to go to Zoom. I'm going to go to 9. I'm going to look at it. It's not too bad. I mean, it's touching some points, but there's other points that are still off. So probably could do better. And again, some of these guys are much more difficult than the ones I'm giving you. You've got to run both regressions and you've got to look at it very closely. So quadratic, maybe not. I'm going to go ahead and go to exponential regression, number 0. Enter. Vars, y vars, enter. That R squared is 0.99, so probably going to work. Zoom 9. Ooh, that is beautiful. That guy is definitely exponential, so that's for sure it. Unfortunately, I did not write the equation down, so I just like to run it again. It doesn't take but a second. Stat, edit, 0, enter, skip the regression equation thing. There it is. So my equation is y equals 0.01. I'm going to go ahead and go 2.6. It doesn't hurt to have, oh, it actually be 2.7. It doesn't hurt to have more values, especially if the first one's a 0. Okay, parentheses, 1.2274. Sure, looks good. Parentheses to the x. All right, so I have, that guy was definitely exponential. I mean, just looking at it, I'm sorry, I rounded wrong for a second there. But there's your equation. I could ask you interpolate or extrapolate using that equation. But for today, today hopefully just an easy day. I'm just going to ask you to write the equation, and that will be it for today. All right, so let's go ahead and do the last one. All right, so our last one, again, the directions are just use the graph calculator, find the line of best fit. So let's go ahead and do it. I'm going to go ahead, and I'm just going to second plus 712 in this guy. Second plus 712. I just prefer to go turn my mode back on. Like, it's just easy enough. Go to mode, stat diagnostics, turn it on, press enter. Go to stat, go to edit, and then type in your data. I'll just go ahead and do this one. This is not too bad. 34, and 39. It's always helpful when the data points end up lining up, so that's nice. Counting evens was easy. 4, 9, okay, looks good. All right, so I am going to go ahead and turn my stat plot on. Second stat plot, turn that puppy on. Boom, on. Zoom 9, boom. Well, looky there. That guy looks pretty linear to me. Okay, so I'm going to go ahead, but I got to prove it. I'm going to go ahead and stat calc. Okay, so I'm going to prove it by actually showing you an interesting fact. I'm actually going to run the quadratic regression first. I'm going to go enter, 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 and you'll be like, that is not quadratic. I'm going to go to vars, I'm going to go to yvars, I'm going to go to function, I'm going to go boop, 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 all the normal stuff. I'm sorry for all the random noises here. Okay, so r squared is 1. Okay, so maybe that's perfect. I'm going to zoom 9. Well, look at that. This guy, he looks linear to me. He could actually be quadratic, okay? Like, he lines up perfectly. Obviously, he's not going to be exponential. I'm just going to save time and not run that one. But quadratic looks pretty good, okay? But I am going to go ahead and go to stat. I'm going to go ahead and run a linear regression number 4. And I'm going to go ahead and store a regression equation. I'm going to go to vars. I'm going to go to yvars. I'm going to go to enter, all that jazz. Okay, well, this one does have a correlation coefficient of 1. The correlation coefficient you can trust. This r squared, you can't super trust. So r being 1 means it's perfect. That is the best you can get. This guy is straight up linear. He is guaranteed to work. So I'm just going to press zoom 9, and this guy's a line. Okay, so I know that the quadratic looked like it worked, and it did work. I mean, if you make this quadratic big enough, like, you can make it work. But really, the only thing you should be comparing is quadratic and exponential. Linear, hopefully, is pretty clear. I mean, that's very clearly linear. Also, I'm going to run the diagnostic again. I keep saying diagnostic. I'm going to run the regression again. If you ever have, and I don't need to run the regression equation, if you ever have r equaling 1, then you're done. Like, that's a line. There's no need to go with quadratic if linear works. So linear does trump all if possible, if it's perfect. But beyond that, usually your only hang up will be comparing a linear, oh my word. Your only hang up will be comparing a quadratic and an exponential. Okay, I cannot talk and write at the same time. Okay, let me write this down. There's my equation. I got y equals 2.5x plus 4. There it is. It's done. But yes, so if it's possible to be linear and looks perfect, stop there. Otherwise, usually exponential and quadratic are going to have minute differences, and you just got to look very closely on that. Also, in the future, if there's ever anything not working on a quiz, don't submit the quiz until after I've fixed it. So for some reason, something's not showing up, I'd rather you turn it in late. I mean, just wait a couple minutes or an hour, or in yesterday's case, a couple hours, and just turn it in late. I'd rather be able to see what your correct answers are than just to have the work submitted. So please do wait if there's ever a mistake, and also let me know, and I'll definitely fix that as soon as I'm able to. All right, your homework should be super duper easy. I just have 3 questions planned out. You're just writing down, is it linear, exponential, quadratic, and you're just writing the equation. So hopefully you just do a really good job on that. If I went too fast, I apologize, but literally it's the same thing every time. Run your regression, look at it by pressing zoom 9, all that jazz. All right, I will see you guys tomorrow.